exponents. Just as multiplication is repeated addition, exponents are repeated multiplication. So this example here, 3 to the 5th power is how it's read, is just 3 times 3 times 3 times 3 times 3. It's 3 multiplied 5 times. In this case, 3 is the base and 5 is the exponent. The base 3 is multiplied by itself 5 times. When evaluating exponents of negative numbers, it's important to keep in mind the meaning of the exponent and the rules of multiplication. That negative can be tricky. For example, negative 3 squared is the same as negative 3 times negative 3, which is equal to 9. That's the same as 3 squared because 3 times 3 is also 9. And both of these have the base of negative 3 and 3. However, when the negative 3 is the base, it's different as when 3 is the base and we are making the answer negative. Basically, you don't have the parentheses. So negative 3 squared, when negative 3 is the base, we see is negative 3 times negative 3, which is 9. But negative 3 squared is like saying that 3 is the base, so you multiply 3 twice, which is 9, but then we're making the answer negative, so it's negative 9. This similarly makes the negative within the parentheses or out of the parentheses or included in the base or not included in the base very important to note when evaluating. This also gets a little tricky with negatives and raising to the third power. For example, 3 to the third is 3 times 3 times 3, which is 27. But negative 3 to the third, even when it's the base, negative 3 times negative 3 times negative 3 is negative 27. So it's just, you can never really assume if the answer is going to be positive or negative. You really have to look at whether it's included in the base or not, what power you're raising it to, and just remember your rules of multiplication. Now, there are special terms for some exponents, for example, squares and cubes. A number raised to the second power can also be said to be squared. And that's because the area of a square of length x is x squared. Here, area x times x gives you x squared. So x to the second, that's why we say x squared. And a number raised to the third power can be said to be cubed for the same concept where the volume of a cube is of length x is x to the third. X times x times x is x to the third. So we can say x cubed. Just another way of saying an exponent of 2 or 3 as squared and cubed. Now, if we have an exponent we need, and that's an operation, we need a way to undo it. Performing an operation and then the inverse of that operation returns us to where we started. So we already saw, we know inverse operations, like if we add 5 to a number and then subtract 5 to a number, we get back to the original number. If we multiply by a number, like 7, and then divide by 7, we're going to get back to the original number. So inverses of exponents are just a little more complicated for 2 reasons. It's not as simple as add, subtract, and multiply and divide. So the first reason is there are 2 possible inverse operations. There's not just one or the other. There's 2 choices. So here we have the equation 16 equals 4 squared provides the answer 16 to the question, what is 4 raised to the power of 2? So one inverse is shown by 4 equals the square root of 16. This provides the answer 4 to the question, what number raised to the power of 2 yields 16? And this shows that the square root of 16 is 4, which we know because it's true that 4 times 4 is 16. You can go back and forth no matter what the question is. The other inverse operation will not be addressed until Algebra 2, but just for completeness, let's talk about it a little bit. It uses logs and logarithms. So, for example, the inverse operation is 2 equals log 4 or log base 4 of 16. It provides the answer 2 to the question, what power must 4 be raised to get 16? More about the power, not really about the base. And again, you're going to learn more about that in Algebra 2. You'll study it more, do a lot of examples, but you should realize that it still exists. We are going to focus more about roots and square roots and third roots, roots in general, but the logarithms are there, all about the exponents and then its inverse.